So here's another little tricky one from my little quest of finding tricky questions. AQA, same series, June 2018, but this one's question 8, paper 3. First part's pretty straightforward. It's just ask you to prove an identity. So I'm just going to quickly go ahead and do that. That's only the, I think it's 3 marks, and it's a precursor to an integration for part B. So first of all, I'm going to deal with the top. I know that sine 2x is equal to 2 sine x cos x. Okay, and then I'm going to look at the bottom and figure out what 1 plus tan squared x is. Now, I mean, I know I could write immediately a replacement for 1 plus tan squared x, but what I tend to do is I tend to start off with my standard identity, sine squared x plus cos squared x is equivalent to 1, because I can never guarantee or be 100% certain that I'm choosing the correct replacement, the correct identity. So I want tan, so I'm going to divide sine, or sine squared, through by cos squared, right the way through each term. And then this way, I can guarantee that I've got it right, okay? Because I don't trust myself to remember things. So here we have tan squared x plus 1 is equivalent to, I'm going to leave it as 1 over cos squared x. I'm not going to change it to sec squared. Okay, so now I'm going to replace these two identities. So the top I'm going to replace as 2 sine x cos x, and then on the bottom I'm going to actually divide through by tan squared x plus 1, or 1 plus tan squared x, same thing. I'm going to divide through by 1 over cos squared x, which is identical to multiplying by the reciprocal of this. So I'm multiplying by cos squared x, you'll get 2 sine x cos squared x times cos x cos cubed x. So as required. So that was our first bit, pretty straightforward and standard 3 marks. I'm going to move on to the integration now. So here we are on part B, and it's a whopping 6 marks. So remember, part A was only 3. So if we could manage to do part A, we'd be only 3 marks in, and this is where sort of the real kind of rewards come in. So if you notice, it's got similarities, but it's quite a little bit different to the identity we just were asked to prove. So I'm going to take my 4 outside, and it's going to be sine 4 theta. Notice it's not 2x over 1 plus tan squared 2 theta. Notice that's not just 1x. So in our identity we just proved, the sine 4 theta was equivalent to 2x, and our tan squared theta was just equivalent to x. So it's a pretty straightforward multiplication of what's inside the trig function. So we can use the identity we've just proved, and if you remember, we just proved that it was equal to 2 sine x cos squared x, sorry, cos cubed x. Whoops, I'll get the power right. Okay, so we're now going to replace 2 theta with x, and we'll go ahead and make our integral. Okay, so it's going to be inside 4 lots of 2 sine 2 theta cos cubed 2 theta d theta. So that's an equivalent integral by using our replacement, our trig identity. Now, this is where quite a few students might just go, what next? And hit a brick wall. And it's about spotting something. It's about spotting using, not necessarily intuitively, but using u as a substitution, u equals cos 2 theta. Because when we go ahead and differentiate that and replace our variables, you'll notice something. So du by d theta, cos differentiates to negative sine, so it's negative 2 sine 2 theta. And then we can write d theta in terms of du, so that's just going to be negative du all upon 2 sine 2 theta. So if we replace this, okay, up here, we end up with 4 lots of, I'm going to bring the negative outside, 2, and I'm going to write sine 2 theta there. I'm going to use my substitution, so that's going to be u cubed, and then d theta, we've taken the negative outside, it's just going to become du all over 2 sine 2 theta. And obviously that's really going to help us out because our sine or 2 sine 2 thetas disappear, and our integral simplifies massively to the integral of, in this case, u cubed du. So it's really quite pedestrian now. Obviously, we're going to integrate u cubed to be 1 over 4 u to the 4 plus rc, and that nicely turns into negative u to the 4 plus c. Of course, at this point, we have to replace our u with our original substitution, so cos 2 theta, so this becomes equal to negative cos to the 4 2 theta plus c. And there's our 6 marks. Okay, so not too bad if we spotted that substitution. Right, thanks.